Okay, first lesson that we're doing today will be lesson 8, and we will talk about when two polygons are similar, and we will also talk about the proportional segments of those similar figures, and we will talk about, and this will actually be what we do first, if we have a triangle and we bisect an angle, we're going to have a special relationship of the different pieces that we get in that triangle when we do that. So first we're going to start off with our definition of bisect. So bicycle means it has two wheels. Bisect means it cuts it into two equal pieces. I need to see everybody writing right now, copying the definitions down. So if we start off with one angle and we bisect it, we put a line through the middle that cuts that into two congruent angles. So this red dotted line is the angle bisector. It is the thing that cuts the original angle into two equal pieces. What we will do as soon as you have this written down is we'll take a triangle, and for one of the angles, we will bisect it. And then we will see what happens with the different parts of the triangle in that. Yeah? So here is our triangle, and you see I have a bisector going down through the middle of it. So it cuts these into two equal pieces. It works best for me if I think of, okay, now you see all these sides, I have A and B sides of the original triangle, but it cuts that third side into two smaller pieces. They don't look like they're equal pieces. D looks longer to me than C does. But it's the easiest way for me to do is to say, if I go in the same direction as the bisector, then if I do the same thing with the sides, A over C, it's going to be equal to B over D. If I just walk parallel to that bisector, I set up my fractions. You may, if you prefer, memorize it left over right equals left over right. A over B equals C over D. But on the example we're going to do next, I turn the triangle. And that's when I start getting confused when the triangle's turned every which way. Or what if I bisected one of those bottom angles instead? Then I get a little bit messed up setting up my proportions. So I think just walk along or walk parallel to the bisector and set up the fractions. So let's try that on this example. See what I mean now? I'm bisecting one of the ones down the bottom. So the triangle looks like it's turned all funky. They tell me BD is the thing that bisects angle B. So I know this is my bisector. I know these two pieces are congruent angles. Now to set up my fraction, since my bisector goes this direction right here, I'm going to go that same direction and write down x over 6, and that same direction and write down 20 over 14. Reduce it if you would like to, or work with it as 20 over 14, doesn't matter. Do the cross product. Maddie, you with us? Please. Okay, let me guess, please. Earbuds out, everybody. So you can simplify that to 10 over 7 if you want. You can do it 14x equals 6 times 20. You can say, oh, x divided by 6. To undo that, I need to multiply both sides by 6. So somehow you get to x is 20 times 6 over 14, or maybe you've reduced the 20 over 14 to 10 over 7, so that no matter what you do with that, you end up with what for your final answer there? Who's reduced it already? What? 60 over 7. So anybody with a question on that one? I'll find my notes at the next page here. Okay, that is another way of doing some proportional line segments, but we can call this one angle bisector, so we don't confuse our two proportional line segments if we're wanting to write down a reason for that statement or a proof or something. When we do one like this with the parallel lines, we'll use proportional line segments for that, just so we don't get the two confused. So this is review. Set up your fractions, equals, solve. All right, so a little bit of help, please. So Lily, how did you set up your fractions? Thumbs up if that's what you set up. And shout out for me, what did you guys get for an answer?
33.
Reduce 33/6. 11 halves, what else? 5.5. So we're all on the right track with that. We take the 19 times x plus 1 equals the 13 times x plus 4. Distribute. Don't let me make a mistake here. So 6x is 33. Divide both sides by 6. Those are both multiples of 3. So reduce that to 11 halves or to 5.5 or 5.5. So good review, good job with that. Changing gears a little bit in this lesson now, we're going to talk about similar figures. Similar figures are going to be ones where the angles all match up. And the sides are proportional. When we are writing the congruence or the similarity statement, order matters. So for one of them, first one we pick whatever order we want for naming it. So I'm going to say this triangle on the left is ABC. I've got all the letters in there. But when I write the other one, I have to get them in the right order. I can't just say I like alphabetical order, so the second one is triangle DEF. Maybe it is, maybe it isn't. What I have to do, so similar is one little squiggle, and then I'm going to write the other triangle. A is the angle that has the right angle in it. What angle has a right angle in the one on the right, everybody? E. Okay, B over here has no mark on it. What over here has no mark? So D has to go next. C has the curve with one tick mark. Which angle on the right has that same measure? So see how it is not DEF. Now I could have done something like, what if I wanted to start with, I don't know, CAB on the left? That would be okay as long as I change the things on the right to match. C matches up with F, so now I'd have to start with F. B on the left, or no, A on the left is the right angle, so then I would need the E. B on the left has no tick mark, or mark of any kind, same with D. So there's more than one way to write it, but I have to make sure that the congruent angles match up. Then the order of that statement also tells us how to do the proportions. If we are doing similar, first two letters over first two letters must give the same ratio as last two letters over last two letters. And that must give the same ratio as first and third over first and third. So that similarity statement says a lot in that. So you have to be careful whenever you are writing those down, or if they give you that as a given, it tells you a lot. So some of the problem sets, I won't have any highlighting on them, but they'll give you a picture of these triangles like that, and they will say, show that these sides have to be proportional like this. That means you have to figure out how to correctly write the similarity statement. But when you look at this picture, hold up fingers, how many triangles do you see? Everybody see 3 triangles in there? We have to figure out which 2 will give us this statement. So what I do with that is I just start looking at the different pieces. I've got AD, AB, AB again, and AC. So first one is AD. I look at my picture. AD is a complete side of which triangle? Smallest, middle, or biggest? Of the smallest. So I definitely must use the smallest triangle. For one of them, I must use triangle ABD. So I figured that much out. Then I keep going. Look at AB next. Is AB a side of the smallest triangle? Yeah. Is it a side of the middle triangle? Is it also a side of the biggest triangle? So it could be the smallest again, or maybe I need to end up using the biggest. So I keep going. Well, AB again doesn't give me any new information, so now I look at AC. Is AC a side of the small triangle? What about the middle triangle? No, it goes too far to be for the middle-sized triangle. So AC is a side of the biggest. So we must also use the biggest, which is ABC. Now, I don't know about the order. I'm just identifying smallest and biggest. So I'm going to write my similarity statement. I'll start with a small triangle and say triangle ABD is similar to, and by the way, I'm just saying they're similar. Are we convinced that's true? Do they both have a 90-degree angle in them? Okay, so we've got one set of angles. Do they both have this angle A in them? So we've got 2 congruent sets of angles. And AA implies AAA. For similarity, if all 3 sets of angles have the same measures, they are similar. Doesn't work for congruent, but it does work for similar. So yes, they are similar. So I'll finish my congruency statement. A in the little one, and we just said A is also in the big one, right? So those 2 have to match up. And let's see, in the little one on the left, D is my right angle, right? Right here, D is my right angle in the little one. What's my right angle in the big triangle? B, so since D was last, B needs to go last over here, which means C needs to go in the middle. So now I've got my similarity statement. Now I'm going to write my proportion. So I'm going to look up here. I need AD from the small triangle. Here's my small triangle. AD are my first and last letters. So I write down AD over the first and last letters, AB. Hey, I got my first fraction. I need to keep thinking through. I did small over big. So now I'm going to do AB. That's the first 2 with the small one over the first 2 of the second one. That will be AC, and that's what I needed. So that's what you're going to do on those. Sometimes there's 2 ways you could do it. Because sometimes, well, you could think of this as being in the second one or in the third triangle, and sometimes there's more than one way you could pick which triangles. But that's the process you use regardless. So, new definition for this problem 29. Star means whatever's on the left, star whatever's on the right. The formula is, take the first one, whatever was on the left, the A, and subtract 3 times whatever was in the B spot, the second one. We'll worry about pound in a moment. We're going to come over here. 4 star 3 is what we're doing first. That's in the parentheses. So that means A is 4. It's the first one. minus, and it means B is 3, so 3 times 3. So we're going to write down that this is 4 minus 3 times 3 inside of that parentheses. And then we will have a pound 5 out there that we'll worry about after we simplify the parentheses. So everybody, what is 4 minus 3 times 3? So we have negative 5, and then we have pound 5. So negative 5 is our first number. It's on the left. Positive 5 is our second number. It is what is on the right for this one. Then we look at, now it's pound, so we're going to take this other definition. We are taking negative 5, pound, positive 5. This definition says 2 times the A, 2 times the first thing, plus 3 times the second thing. This says A is negative 5, so we are going to write down 2 times negative 5 plus, and it says B is positive 5, so plus 3 times 5, so plus 15, and what will that give us, everybody? That gives us negative 10 plus 15 is 5. Everybody feel okay about that one? It's kind of weird. It's just saying, if you have a star, use this formula. So if you want, write down your formula and write down, I need to do 4 star 3. So A is 4, B is 3, plug into the formula. That's all you're doing. But notice, then it is, that was in parentheses, so the star was first. And then on the right of that, you had to put pound 5. Number 30, when you do that, I think, switch the order around. Yeah, number 30 has pound out on the left. Be sure you keep that 2 pound out on the left. So what I want you guys to do now, do number 30, and then 28, and then 26,